Hello people, welcome back. The question is from GATE 2019 exam. This one is for 2 marks. Just have a look at the statement, then I'll explain it. They are saying, suppose that in an IP over Ethernet network, a machine X wishes to find the MAC address of another machine Y in its subnet. Which of the following techniques can be used for this? Now you can have a look at these 4 options. I'll come back to the options once I explain a few things. Okay. So they are saying X and Y are in same subnet. Suppose this is the subnet. Machine X is here and machine Y is here. Okay. Now X wants to know the MAC address of Y because X wants to send some message to Y. And you very well know at data link layer, the MAC address of Y has to be written in the destination address. Okay. So X cannot communicate with Y until it knows about the MAC address of Y. Okay. Now suppose X knows about the IP address of Y. Okay, using some DNS or whatsoever, X knows IP address of this machine. What will X do to get to know the MAC address of Y? X will send a ARP message. ARP stands for Address Resolution Protocol. This protocol is used to convert a IP address into its respective MAC address. So X will send a ARP message saying, I know IP address of some machine. Please reply me back with your MAC address. Okay. Now X does not know what is the MAC address of Y. That means even that ARP message will not be delivered to Y. Okay. So what is X going to do? X will actually broadcast a ARP request. That means X will fill F in the MAC address part, that is broadcast address. So each and every node in this network is going to get a ARP request. In that ARP message, X will be saying there is some machine whose IP address is so and so. Please reply me back with your MAC address. Now this machine will also receive that message. This machine will see it is talking about some IP address Y. Its IP address will not be IPY. Okay, suppose the IP address of this machine is this. IP address of X is X IP. Okay. IP address is this. MAC address is X MAC. Okay. Here the MAC address is Y MAC. Now all of the machines in this subnet will receive that message, the ARP request sent by X. But only the machine whose IP address is mentioned in that ARP request will reply. Okay. Now Y will also get that and Y will see someone is talking about my IP address. So Y will get to know that I have to reply with my MAC address. Y is going to send a ARP response. Okay. Let's look into a bit more details. See, at network layer of X, there is a protocol called ARP. ARP protocol is going to prepare an ARP request. It will look like this. Now, the network layer of X is going to prepare a ARP request message. It will look something like this. Now, there are a lot of other fields. Maybe 4 or 5 other fields are there that I am not discussing here because these are the important ones. Okay, have a look. This is the information about sender. That means who is sending this ARP request. IP address of sender is mentioned and the MAC address of sender is mentioned. This is the information about target. The word destination is not used with respect to ARP messages. Okay. So in ARP request, we use the word target. So target IP address is YIP and target MAC address is not known. So just leave it empty. It will be all zeros. Okay. Now this message needs to be delivered to Y. Okay. Actually, We don't know the MAC address of Y. That is the basic problem. So X cannot just directly give this message to Y and say tell me your MAC address, because just for delivering this message to Y we need MAC address. Okay, that is the basic problem. So what is X going to do? X is going to send this message to everyone. Now to broadcast this message to every node on this network, the data link layer of X is responsible. See, this is the network layer. Below this will be the data link layer of X. Suppose this is the DLL. Now, DLL is going to prepare a frame. In this frame, this ARP request message will be encapsulated. Okay, so suppose this is that message, the data. It will add the header and tailors and all of that stuff. Okay. Two important fields that DLL is going to add is the source MAC address, which is XMAC. Okay, this is the source MAC address. Destination MAC address is not known because we want to send the message to Y, but we don't simply know the MAC address of Y. So what has to be filled here? In destination MAC, X, this node will fill all ones. It is 11111 48-bit ones. That means FFFF. Okay. So 48-bit ones means this is a broadcast message. X will now just send that message. This node will see that destination MAC address is all ones. This node will think that this is a broadcast message. That means everyone has to receive it. So this node will just receive that message. Similarly, this node will also receive it. This node Y will also receive it. Okay. Every node of this subnet is going to receive the message. Now, data link layer will just remove this extra information, and this ARP request packet will be given to network layer of this node as well as this node. Okay, each and every node will get that ARP request packet. By the way, this router will also do the same. Okay, this default gateway or router will also receive the ARP request packet. Now have a look. Network layer of this node will see someone is asking about MAC address of this IP address. Okay. This machine's IP address is not YIP. Its IP address is something else. So it will just simply discard that ARP request. Data link layer will receive it, but upper layer, the network layer, is going to discard this request. This machine will also do the same. Network layer is going to discard that ARP request. But for this machine, network layer will see someone is asking what is the MAC address related to this IP address, which is YIP. Now this will see someone is asking about my MAC address, okay, because its IP is YIP. So it is going to respond to this ARP request, okay. Now, will this node Y actually broadcast the message? No. This node Y knows about MAC address of X because X has already written its MAC address in the request packet only. Okay. So for getting the MAC address, X broadcasted a ARP request, and for replying back, this Y it will not broadcast. It will just send a message to X only. So this Y will actually send a unicast message. That means in the destination MAC address, it will write the MAC address of X. So only X will receive, only the data link layer of X will actually receive that message. Okay. All other nodes will reject it because in the data link layer addresses, the address mentioned is related to X only. Okay. So let me just repeat this point. X will send a ARP request to everyone. Everyone will receive it, but only Y is going to reply. And in response to that message, Y is going to send a message only to this one. Okay. Now I told you that the request packet will be rejected by these nodes. Okay, they'll not directly reject it. There's something called ARP cache. They'll update their caches and all of that stuff. Then they are going to reject it. Okay, leave about that stuff. Okay, I've already discussed it in the theory lectures. Anyways, now let's just focus on this question. So let me read the options. Option 1 says X sends an ARP request packet to local gateway's IP address, which then finds MAC address of Y and sends to X. No, we have seen that X, this is the local gateway or the default gateway. Option A says X is going to send a message to this one. We have already seen that this is not the case. Okay, because both of them are in same network, X does not need the help of this default gateway. X will directly send message in its entire network. Okay. So option A is wrong. I'll come back to this option once again. But for now, just believe that it is wrong. Option B says X sends a ARP request packet to local gateway's MAC address, which then finds the MAC address of Y and sends it to X. This one is also wrong. Option C says X sends an ARP request packet with broadcast MAC address in its local subnet. This is true. Option C says X sends an ARP request packet with broadcast MAC address. Okay, that means everyone must receive this packet. X sends an ARP request packet with broadcast MAC address in its local subnet. Yeah, this is true. In the entire subnet, X will send an ARP request because X knows that Y and this X, both of them are in the same subnet. Okay. And option D says X sends an ARP request packet with broadcast IP address in its local subnet. No, this is false. This won't work. Some of you might think that option D is true. But have a look. X will send a message with broadcast MAC address. Okay, it cannot use broadcast IP address because if X uses broadcast IP address, that means X tries to broadcast at network layer. Let's see what will happen. If you want to broadcast using IP addresses, you will fill 255.255.255.255 here. Okay. This is the limited broadcast X, limited broadcast address. That means network layer of X is saying that deliver this message to network layer of each and every node. But if you do so, each and every node will receive this message at network layer. Okay. See, earlier network layer of these nodes was rejecting the message because they were saying the message is not for them. But if you fill 255, 255, 255, each and every network layer will accept this message. And now, out of these three nodes, no one exactly knows who has to reply. It's like everyone will reply. Okay. So if you omit this Y IP, you cannot simply identify this machine. Okay. So no one knows who has to reply to this message because everyone knows that everyone has received the broadcast at network layer. Okay. Option D is false. Now let's come back to option A and option B. Option A says X sends an ARP request packet to local gateway's IP address, which then finds the MAC address of Y and sends it to X. Option B says X sends an ARP request packet to the local gateway's MAC address, which then finds the MAC address of Y and sends to X. See, for these two options, I need to discuss some more basics. There are four possibilities. The first possibility is X and Y are in same network. That means the point that we just discussed right now. And X knows that. Okay, first possibility is they are in same network and X knows that. Second possibility is they are in same network but X does not know this point. Okay, this is the second possibility. Third possibility is X and Y, they are in different network. Suppose this machine is Y. Okay. Now X and Y are in different network, but it is possible that X thinks they are in the same network. Okay. So even though they are in different networks, X might think that they are in same network. This is the third possibility. And as you might have guessed, the fourth possibility is they are in different networks and X knows this fact. Okay, X thinks that they are in different networks and they are actually in different networks. Now the question arises, how does X knows that they are in same or different network? ISP will provide four things to each and every node: DNS, IP address, default gateway's IP address, and the subnet mask. So X has a subnet mask. Using the destination IP address and the subnet mask, X can determine whether the destination and this node, whether they are in same network or not. Okay, now if you alter this subnet mask, you can trick X to think that they are in same network even if they are in different network. Okay, and vice versa. Now, based on the subnet mask provided by the ISP, X will assume they are in same network or different network, and the reality might be different. Okay, suppose X and Y, they are in different networks and X knows this fact. Then what will X do? X knows that they are in different network. Now there is no use of broadcasting any message in its own subnet. So X will not send a broadcast ARP request. Instead, X will just forward the message to router. Okay, it will forward the message to default gateway and X will say, now it is your responsibility to send this message to Y because Y is not in my network. Okay, X might not know the MAC address of this router. Okay, X wants to send a message to this router for the purpose of sending it to Y. Now X might know the address, X might not know the MAC address of this router. In that case, X might send a broadcast ARP request asking the MAC address of this router. Okay, so first the message will be sent here, then it will be forwarded to this Y. Second possibility is X and Y are in different networks, but X thinks they are in same network. Okay, the subnet mask that is provided to X is provided in such a way that X now thinks they are both in the same network. Now because X thinks they are in the same network, X is going to send a broadcast message asking about the IP address of Y. Okay, the message will be broadcasted in this entire network. No one will reply because Y is present here. Y is not a part of this network. X has broadcasted a message in its own network. No one is going to reply. What then? In this case, proxy ARP comes into play. This router will also receive that ARP message. Now router will see, router knows the reality. Okay, router will see that X is sending a ARP request as a broadcast message to this node, but this node can never be reached from here because it is in a separate message. So on behalf of X, router will be responsible for forwarding the messages. Okay, router will reply, router will give a ARP response saying that I know how to reach to this point. You just forward the messages to me. Here is my MAC address. So this router is going to respond with the MAC address. The router will send the ARP response in this case. So this router replies with its own MAC address. X keep on sending the messages to this router and router will then forward it. Okay. What is the other possibility? Other possibility is both of them are in the same network, but X does not know this. X thinks that Y is in a different network. In this case, X will think that because Y is in a different network, so router is responsible for forwarding messages to X. router or the default gateway. Okay, I'm using these words interchangeably. Now X will send the message first to this router. This router will then send the message to Y. Okay, we can actually make X think that X and Y are in different network by altering the subnet mask that is provided to X. Okay, now this node is going to send a message to this one, then this node is going to forward it to Y. Okay, that means X needs the MAC address of this router. There is a possibility it has already communicated with the router, so it knows the MAC address. And the other possibility is X is unaware of the MAC address. Then X will first send the ARP request asking about MAC address of this router. Then X will forward the actual message to this router. This router will then forward the actual message to Y. Okay, the communication will take place in such a way. Now, if you read option A and B, you will realize that both of them are incorrect because they are saying X sends the ARP request to the router. Okay, that will not be the case because in question only they are clearly mentioning X wants to know the MAC address of node Y in its subnet. So at least X thinks that Y is in the same subnet as that of X. So because X thinks that Y is in same subnet, X is going to send the ARP broadcast message using broadcasting at the MAC layer. Okay, using the MAC broadcast address, that is all 48 bits of ones. Hence option C is the correct one. Okay.